Take a look at this sword. It's called the Damascus sword. It belonged to Saladin, one of the most famous warriors in history. This sword has a yield strength of 1600 megapixels. The yield strength of a metal is the stress at which it begins to bend, and it can never go back to its original shape. The yield strength of Wootz steel is 5 times higher than the cast iron pan you have in your kitchen and twice as hard as any hammer that you have in your house. Now take another look at this sword. It's also very beautiful. Swords made out of Wootz had patterns that look like the rungs of a ladder. Other swords even had swirls that looked like rose petals. And still others had cloudy bands that resembled streams of water. Hence the name Damascus. The name Damas in Arabic means flowing water. They weren't called Damascus swords because they were made in the capital of Syria. Wootz was made in India as far back as 1100 BCE in sites such as Hallur in Karnataka and many places in Tamil Nadu. And yet the science behind these swords was unraveled only in the 20th century. Today, I'm going to explain to you what some of the world's most famous scientists, from Michael Faraday, Pavel Anasov, and the great MIT metallurgist Cyril Smith found. In the next 5 minutes, you're going to learn about Wootz steel. You're going to take a deep dive into what made the steel so strong, and you'll learn how ancient sword makers forged these amazing patterns. So let's get started. Wootz has been made in India since 1100 BCE. In fact, the name Wootz is derived from ukku, the Kannada word for steel. In Tamil, the word urukku means to melt or to ooze. Ooze is a very poetic word, which is to say that it lends itself to different meanings. For example, when Antonio Banderas comes into a room, a person might say, "Ah, look at him, he oozes class." But when I come into a room, that same person might say, "Ah, look at him, he's oozing pus." One word, many meanings. The Wootz swords were very famous around the world because of their strength. They were so strong that following the Indian Mutiny of 1857, one of the first things the British did was to get rid of all Damascus swords in the country. In fact, the swords were so strong that they made the leap from the world of fact to the world of fiction. In Sir Walter Scott's Talisman, published in 1825, he tells of an encounter between King Richard I Lionheart and Saladin. In the story, King Richard cleaves an iron bar into two with his sword. Saladin doesn't look so impressed. He asks King Richard if he could tear apart a pillow with such ease, and Richard says, "No way, Jose," or "No way, Saladin." Richard says that a pillow doesn't offer any resistance, which is a must for splitting something in two. So Saladin takes out his Damascus sword. He takes it near the pillow and gives it the briefest of touches, faster than a fleeting kiss, and the sword just falls apart in two, as though of its own accord and not as a result of the act of violence. This begs the question, how did these ancient metallurgists get these swords to be so strong? Before anything, let's understand what steel is. Steel is an alloy of iron and carbon. As you might know, iron is the Beatles or Taylor Swift of metals. It's very popular, and of all the metals, it has had the most impact on history. In fact, of the total global annual output of metals, more than 95% is iron and steel. Iron is the fourth most widely distributed element, forming about 5% of the Earth's crust. Now, let's get to the difference between iron and steel. That difference is the difference between Peter Parker before he was bitten by a spider and after he was bitten by a spider. Iron by itself is like, you look at iron and say, okay, I see you. But steel is iron with a carbon percentage of 0.5% and 2%. When you see steel, you say, whoa, or even, whoa, mama. It's that strong. The amount of carbon affects how soft, hard, brittle, or flexible the metal is. Iron ore, which is raw iron, usually contains oxygen in the form of iron oxides. Carbon helps remove the oxygen by bonding with it to form carbon monoxide and carbon dioxide. This chemical reaction leaves behind nearly pure iron. As you add carbon to this pure iron, the metal forms new internal structures or phases. There's ferrite, which is soft and ductile and is found in the soft iron wires used in construction. There's cementite, a hard and brittle compound of iron and carbon that you can see in the cutting edges of hardened tools like chisels. And then there's pearlite. That's a mix of ferrite and cementite, and it's arranged in thin layers. This structure gives steel both strength and toughness. This is the kind of steel you see in railway tracks and structural steel used in buildings. Wootz steel is iron jacked up on carbon, often around 1.5%. At this high carbon level, the hard cementite forms into tiny hard spots into the softer iron. Now this begs the question, how did these blacksmiths get carbon into steel? They use the crucible steel method, where pure iron pieces are packed with carbonaceous material, charcoal leaves, banana stems, and they put these inside sealed ceramic pots. These were fired for hours, sometimes up to 24 hours, at temperatures around 1300 to 1400 degrees Celsius. The iron needed to be cooled slowly. This is really important for Wootz steel. If you cool the iron so fast that you quench it in water, you end up getting something that's hard and brittle. I'm going to tell you 3 ancient methods that blacksmiths use to cool Wootz steel slowly. 2 are normal and 1 is gross. Tell me if you can guess which one is gross. One of the methods Indian blacksmiths used for slow quenching was to thrust the sword into the sap of a banana or a plantain tree. The second method was to thrust the sword into a stomach of another human being. And a third method was to hold the sword in front of you as you galloped on a horse, and the metal got air quenched. Now, if you didn't guess that option 2 was the gross method, then all I have to say is thank you so much for watching my video, Dexter. This brings us to the next question. How did the blacksmiths get the wavy patterns on the blades? Wootz's bands, called Damascus patterns, form due to carbide banding during slow solidification. When the blade is forged and etched in acid, the carbon-rich cementite shows up as bright lines while the ferrite appears as dark. Some smiths enhance these patterns with grooves and dimples, creating motifs like Muhammad's ladder or rose patterns. So we have Wootz, which was made as far back as 1100 BCE and only understood by science in the 20th century. In all that period in between, the sheer strength of the blade and the exquisite delicateness of the pattern give Wootz this great sense of mystery, awe, and wonder. Even the great Russian novelist Pushkin wrote a poem about Wootz. "All is mine on earth," said gold. "All is mine," said iron cold. "I will buy it all," said gold. "I will take," said iron cold. In this poem, gold means wealth, and iron, which actually refers to Wootz steel, is power. Isn't that a wonderful poem? What Pushkin didn't write was that when money and power come together, they have a chemical reaction and create something called a douchebag. I want to end by paraphrasing Cyril Smith's concluding essay and understand from this beautiful essay why people have remained obsessed with Wootz over the centuries. Now, the human eye receives visual information in 2 dimensions, but our brain converts this image into 3 dimensions. And to do this, it uses cues like shading, texture, and edge variation. This is happening all the time. Now, more the variation, the harder our brain has to work, and the experience becomes a lot more immersive and delicious. Handcrafted objects like the Damascus swords, because they are made by hand, are never quite the same. Every time you look at one, you see subtle variations in the surface, the curvature, the reflection of light, and the texture. These variations help the mind build a rich internal model of depth and form. When a craftsperson makes something, they are also drawing on centuries of tradition. How their father made the swords, how their father's father made the swords, how their father's father's father made the swords, unless that gentleman died of cholera. When machines make stuff, there's no variation. Everything made by a machine ends up looking the same. That's why there's not as much room for visual stimulation. I wonder if using the word visual stimulation makes this video R-rated. Anyway, craftsmanship enhances visual depth and tactile perception in ways that mechanical precision typically does not. And objects like Wootz steel and the Damascus sword serve as reminders to respect human contributions, because ultimately they deliver a more satisfying experience. There are powerful tools made by douchebags, but they will never, ever quite be the same as something forged by the human hand and created by human thought. I hope you enjoyed this video. Please consider subscribing for this video so that we might meet again. I also hope that you have a wonderful 7 days and enjoy the week that lies ahead. Bye.